And when I invite Francis Wray now.
Okay, the objective of my short presentation is to give a very brief overview of what HPC cloud-based simulation and data analytics means, and I'll speak briefly, and then I'll hand you over to presentations from two very concrete real-world applications of this sort of technology. What is HPC cloud-based simulation and analytics? Well, it's better design using advanced simulations. Suppose I'm a teapot manufacturer and I want my teapots to pour better, then I can use computational fluid dynamics to optimize the design of that teapot, and then I can change my manufacturing process to reflect that design. Suppose I run a factory. I want to understand how that factory runs by putting sensors and actuators across the equipment. I want to understand how that factory really works so I can optimize its operation. Both of these types of optimization require very significant computing power. And this raises a very significant barrier for small companies because they simply can't afford to buy the required computing hardware. They might not have the necessary in-house expertise. So a pay-per-use one-stop shop is at least one answer to their problem. They can buy this sort of technology as they need it, and they don't have to put out a significant capital outlay. So let's look at some potential examples of what this type of high-performance simulation, data analytics and optimization can look like. We can monitor the condition of a vehicle via real-time data processing. This would enable better vehicles to be designed because the manufacturers would be able to see where the problems in their existing designs lay. Similarly, the positioning of gas and flame detectors in hazardous manufacturing and production plants could again be optimized to make those plants be safer, to make those plants operate in a better way. So let's look now at two specific examples. The first one is from a company based in Macedonia called Microsam. They manufacture pressure vessels, the sorts of pressure vessels that hold compressed gas in the back of a car, and they manufacture them from composite materials, that's glass fibre and resins. There are very significant advantages in using this composite materials. These advantages are that it's very light, it's much lighter than steel, it's much lighter than aluminium, and it's cheaper to manufacture and use. There are significant advantages in designing pressure vessels by using computer-based simulation. These advantages arise because it's much easier to simulate in a computer a design than to make an expensive prototype. Making prototypes is not only expensive, it also takes a long time. So if you can do this quickly in an advanced computing environment, then you can improve your design processes, you can produce better products, and you can improve your bottom line on profit. Another example is from an Austrian company called Sestec. They produce bioreactors. In bioreactors, you can grow drugs, proteins, nucleic acids, vaccines, and so on, a whole range of biological products. To understand what goes on in a bioreactor, you need to model the multi-phase flow, very complex flows in your reactor, and this requires very advanced computational fluid dynamics. Again, significant compute resources are required, They're needed to model accurately what goes on in the bioreactor, and they're also needed to model very long process times. Okay, so that's a brief introduction to what simulation, high-performance computer-based simulation is. It's an example of introduction to what high-performance data analytics is. So now let's get on with the main acts and have the two speakers who'll give a detailed presentation on how they are using high-performance computing in their business. Thank you.